Hello, my name is Nick Brueggemann. I'm a developer here at Esri. I'm joined today with my colleague David Jacobs. We're both in the professional services division out of the St. Louis regional office, and we're going to talk about Web App Builder, use of it today. Really digging into the session's called Enterprise Deployments, but we're also going to talk pretty heavily about enterprise development and how to use Web App Builder as a development tool, really as a framework for building large scale applications. So a little bit more about what it is we do and why we do this session. So, oftentimes, there's the multiple versions of Web App Builder where you can use the out-of-box stuff and you're just configuring applications. It doesn't require any development at all. Then there's the level of applications where you're getting into writing custom widgets. We're really a bit beyond that in this session. We're going to talk about really how to use Web App Builder for a bunch of different scenarios, and really we're writing enterprise level applications that require a lot of custom code and have a lot of features beyond just the out of the box functionality that's in Web App Builder, and even more than just creating custom widgets. So these are the things that we're going to go over today. We're going to dive a little bit more into what we mean by enterprise development. We're going to talk about an app building process and pipeline. So really you can think of this as the way you get your application from source code that you've got written all the way out to a deployment and running on a server. We use pipelines to do that, and we'll walk through each stage of that pipeline. We're going to talk about source control patterns and how to source control the code that you've written for your applications. One thing that we deal with a lot is deploying our application into multiple environments, be it testing or development, testing, and production, those different environments, and how we change the configuration really of the application so we can push it to those different environments without making a whole bunch of code changes to the application. We're going to talk about architectural patterns, and again, this focuses a lot more on the code that's not really in the widget itself, and just how to maintain good what we think are design and architecture principles when using Web App Builder, and just some various tips and tricks that we've learned over the course of the several years now that we've been using Web App Builder for doing this sort of development. So thank you for joining us, and we'll dive right in. All right, so let's take a minute to talk about really what this presentation is going to cover and the topics that we're going to talk through and what we are considering to be enterprise application development. So like the first bullet point says, it's generally a project that you've got more than one developer contributing to the baseline. So this is where the source control concepts and making sure that you've got that set up and you're allowing multiple people to commit changes to a common repository really come in handy. We've got some different paradigms of how we think you should organize your source code and what you should put under source code control that we think are helpful and have worked really well for us. It's typically a project that's deployed into multiple environments. Like I had mentioned, it's where you've got a development server, staging servers, and production servers, and you push the application through those different environments. The development environment, really the environment that the developers have access to, and basically free reign over to push changes as they're making them, essentially. And then a staging server that's a little bit more restrictive, that has maybe a bunch of changes all together integrated into the same baseline that you might get QA testers involved in testing, and then another production server, an environment to push out the actual production applications that the clients are going to use. And then it's usually a project that's got quite a bit of significant complexity behind it. So it's definitely more than, just I've got a web application, I've built it with Web App Builder, and I've got this one custom widget or maybe two custom widgets that I've created to add on to some workflows. It's really getting into the finer level details where you're adding some significant application logic to your app, and you're customizing widgets and maybe taking some of the out-of-the-box widgets that exist and tweaking them and extending them, and then maybe even getting into some of the Web App Builder framework itself and modifying it. In the project work that I've done over the past couple of years, we've done all of these quite extensively. You'll run into, when you use Web App Builder, you get a lot of stuff. That's why I think Web App Builder still, even when you're customizing it to the level that we are, in some of these examples, there's still a lot there that you want to benefit from and use. So when you look at your options between customizing Web AppBuilder or maybe rolling your own from scratch application, there's still a lot of goodness with Web AppBuilder, but that comes with, the desire for maybe some customers to say, well, we like that widget, but can you make it do this too? And can you tweak it to do this? Because that's what we want it to do. So these are the scenarios that you'll get yourself into that, you've come across and have ideas on how to help. So one of the concepts that we want to introduce is a build pipeline. So this is a way to automate the entire process of building your application from source code checkout to configuring it for the right environment to getting it deployed to a server. So we use Jenkins to do this. And this is one of those things with, I think, the Web AppBuilder Developer Edition. It's oftentimes not one of the most intuitive things to do. So we'll walk through how we do it, but I'm going to take a minute to talk through each of these steps, and we'll go through each one of them in a little bit more detail. So we're going to go through source code and talk about what we source code control and how that's done. That's the checkout code part. We're going to walk through how we build our applications. So, if you're used to the way that Web AppBuilder works, the Developer Edition, you go in and you use the WYSIWYG editor to create an application. And then you use the WYSIWYG editor once you've got your application configured and you've got maybe your custom widget in there. You'll use that to download your application and bundle it up. We typically don't use the WYSIWYG editor for a lot of that stuff. We've written our own custom steps to handle that. And most of the time we find ourselves not using the WYSIWYG editor anymore. We're to a level where we understand the configuration files that Web AppBuilder is using behind the scenes, and we're modifying those. So we'll walk through how we build the application when we're doing it, not with a WYSIWYG editor. We'll talk about how we configure the application for different environments. If you look through, take a widget that you've got, for example, it'll have a configuration that's probably pointed to some URLs. Those URLs will be specific for a given environment. If you've got multiple environments, you're going to want to modify those URLs so your application is configured for the environment that it's deployed to, be it development, staging, or production. We're going to talk about how you can unit test your code that you've written, which is always a good practice. You want to make sure that you've got automated unit tests that are integrated into the pipeline. So you probably want to set things up so that when you're committing code to the repository, it's automatically running the unit tests and not letting anything into the repository if the unit tests fail. Minimizing the application. You don't really need to do this for the development environment or maybe even the staging environment. You might want to do it for staging, but you want to do this for production so that you've bundled your application up, you've made it as small as you can, and this is really going to help load times with the application when users are using the applications in the browser and loading them up. And then we're going to talk about some ways that we actually automate the deployment of the applications. And this, I think it's important to note that the way that we do things is kind of the way that we implement a lot of this. It's really conceptually what we're doing that is the main focus of this. You can implement these steps however you want and what works best for you, but we'll talk about what we've done and how we've done it. The first step in the pipeline deals with checking out the code. You can't check out the code if you don't have it under some sort of source code control. So source code control is essential for team collaboration. If you've got more than one developer that's contributing to the baseline, you should have your code in source code control somewhere. It just makes things easier. It makes it easier for you to share the code and make the same commits and do diffs on the different commits so that you can merge it all together in a cohesive baseline that you're both contributing to. If you've got 4 or 5 team members, I don't really know how you would do this without source code management. You can use GitHub or GitLab or Subversion. Any of them really work. We use GitLab right now mostly for a lot of the projects that I work on, but there's just really little subtle differences between them. Use whatever is best for your team. There are a few different ways that you can implement source code paradigms for Web AppBuilder Developer Edition, and we're going to go through those. But ultimately, what we're going to talk about is a suggestion that we have. There's what we think are some pros to doing it, but you need to do what works best for the team that you're working in. So one option is to not have any source code control at all. Like I said, I don't think that's a good idea. Another option is to source control everything. So this would be a scenario where you downloaded Web AppBuilder Developer Edition and you create your applications in there and you just source control the whole thing. You don't need to do that. It's not a good idea. The Web AppBuilder Developer Edition is versioned, so you can always get back to a previous version. If you lose the one that you've got, you don't need to stick that in source code control. Another option that I see a lot is where somebody has built an application and they've used the WYSIWYG editor to generate it, and then they take their application that is, either they've downloaded it from Web AppBuilder or they've gone and pulled it out of the Web AppBuilder folder hierarchy. And this screenshot here is the folder structure of Web AppBuilder itself. If you've created an application using the WYSIWYG editor, if you look in the server folder under the apps folder, you'll see numeric folders in there that increment for each application that you create. So when you go into Web AppBuilder and you say, export this application, it's basically zipping up that folder and giving that back to you. It's that folder that we see a lot of people will take and put all of it in source code control. Our suggestion is to do the last one here, and that's to only keep the code that you are changing in source code control. So there's no need to source code manage all of the out-of-the-box Web AppBuilder widgets, even if they're in your application. The build process that we go through next will show you how to merge your source code with the Web AppBuilder code to create this application without using the WYSIWYG editor to do it, and without sticking all of the out-of-the-box code in your source code repository. So we think this is the best way to go. And often this is what our build structure looks like. You've got whatever your project that you're working on. We've got a build folder in it that is the build system that we've written that goes through all of the steps that we are talking about in the build pipeline, the testing phase, the deployment phase, the app building phase. That's the build system that we typically end up writing. And then we've got a source folder. In that source folder is our widgets that we've written, and then you can call it whatever you want, but there's also in Web AppBuilder, there's a libs folder, and any of our custom application logic that's not user interface logic, we typically throw in a libs folder. So that's what that source custom libs is. And again, widgets is any of the custom widgets that we've written. And then we end up putting the Web AppBuilder Enterprise Edition or Developer Edition inside this, but we don't source code control it. We add it to gitignore, so it's in the folder structure, but it's not part of what gets committed to the repo. So that's for source code. That's typically what we found works best for us. Next, I'm going to kick it over to my colleague David, and he's going to go through how we take the source code, how we take the code in Web AppBuilder, and how we automate the merging of them together to give us the application that we're going to be dealing with.
Thanks, Nick. So to talk about building web applications, I'll talk about the steps needed to create a web application without using the Web AppBuilder's WYSIWYG editor, and then I'll give a gulp example and a manual example. So the high view of it is that we take the files necessary from the STEM app folder and we put them into our own custom, in this case, my app folder that will become our web application folder. And then we take the code files from our custom code files that we need and we put them inside the my app folder as well. So the step one in doing this in gulp is we have a gulp task built that we can just run gulp install, and it'll take the files that we need from STEM app and it'll put them into our my apps directory. Let me show you. So we get to choose which environment we want to use. We'll use local development. And it's telling us that we need a clean JavaScript API and a clean Web AppBuilder extraction. All right, now that that's done, I'm just going to run gulp. That starts our build system. It starts a web server and launches our browser to our web server, or to our web application. Configured and ready to go based on what's in our source and what came from StemApp. And here are some out-of-the-box widgets. And here's our custom widget, and it doesn't do anything right now. It just says my widget. So to show you what that does in a little more detail, what is happening is on the top left, I'm going to go to the StemApp directory that we use as our blueprint. And then on the top right, I'm going to go to our source directory that has our custom widget in it. And on the bottom, I'm going to go to the folder that gets created to become our web application. And if I were to do this manually, as an example, I'm going to create just a temporary folder here called manual and go into it. And the process for doing this manually is in the StemApp directory, there's a file called copy list, and it gives us a list of the files and folders that our web application is going to need from StemApp. And so based on that list, I can copy everything that list references as highlighted here. And I just copy that into our web app folder, in this case our manual folder just for this example. And as you'll notice, it's missing the themes and the widgets. The next step for creating our web application, also if we come into libs and compare it with what's in our libs has a few files that, or a few folders that the StemApp libs does not have. And so what we're going to do is just copy all of our files from source and copy those down into our web application, in this case manual. So that created the themes and the widgets directory, but if you look, we're not doing anything custom with themes right now, and our widgets just has that. And also in our configs, we're missing the custom configuration for our specific application. So if we come to our application and what we need to do to figure out what theme and what widgets to come to pull in, we need to look at let's look at our project in Visual Studio Code. Here in our configs directory, we have our web app listed. This is the JSON that will become the config. This is the JSON config for what will become our My App web application. And I'm going to look in here to see what theme. We're using the foldable theme. So in the StemApp directory, if I go to themes, and I can go find foldable theme and drop it into our themes directory for our manual application. And then in our widgets, I go back to our StemApp widgets list, and there are a lot of widgets. The way we find out which ones we need, we would come into our config for our application and interrogate the widgets on screen widget list. They're all listed here in this URI. Foldable theme widget has a header controller that we need. We have a scale bar, a search, coordinate. There's quite a few, and then also in the widget pool, there's a list of widgets that are needed. For the sake of this example, I am just going to come to our StemApp widgets directory, and I'm actually just going to copy all of the widgets. All right, so with all those widgets copied over, we now just need to go get the configs figured out, and that's actually in our widgets configured file. Just going to copy over those. So now if I go from my app to manual, it should work. If it doesn't, we're going to go to our dev tools to see what's going on. Oh, yeah, there's one more thing. And for this, I'm going to go into our apps folder, go into manual, and I'm going to go look at the env.js file. This is the file that tells Web AppBuilder, or the web app that you've created, where to look for the JavaScript API. And for this, we have it locally at ArcGIS test.js-js-API. So now when I refresh, okay, so here's one more thing we're missing in the manual process. Bottom one is our application. We're missing the config.json file. And that can be found, again, under configured, under apps, myapp.json. I'm going to copy that down here, and then I'm going to rename it to config.json. Now when I refresh, there we go. I'm going to close the dev tools and just let it go. So now we can see that the My widget is there and the measurement is there. And I'm going to come back to the My app. So we have the manual, and then we have the My app, which is managed by the Gulp system. I'm going to come back into here and make a change to that widget that we've got. Call this my 2020 Dev Summit demo widget. Make that save. And the Gulp task saw that it had changed, and it processed that change right away. So if I come back here and I refresh the My app, which is managed by the Gulp task right now, refresh that, and also refresh the manual project, and check the My widget content. My widget on this one says my 2020 Dev Summit demo widget. My widget on the manual does not yet. In order for the My widget on the manual to see that change, I need to come over here and in the manual app, come to the widgets directory, come to the My widget file. In the source code, I'd come into the widget that changed, grab the file that changed, and copy it over to and replace it in the manual project directory. Then when I refresh manual, it will also have that change. So the one on the left is the My app, and it's managed by Gulp right now. As any change in the source gets automatically copied over into the My app folder. Any change in source does not get copied automatically over to the manual by Gulp. I have to manually do that myself. And so as I go in my application and I'm coding and making changes, it's as easy for Gulp. It's as easy as just hitting save. As soon as I save it, Gulp has responded. In fact, let me do a side by side with the Gulp process. So as I hit save over there, the gulp task saw that it was changed, and it processed, it did some extra things like formatting, applied formatting to the file as well, and then copied it over where it needs to go, so that when the web browser refreshes, it'll have the latest copy of the widget code or any other source code that changed. And we can see that right there in the application. Whereas the code that's in the manual project is still behind. It doesn't have the latest. That would be something I would have to manually copy. But as soon as I do copy it over, place it, and refresh it, then they're linked up again. So the point of this exercise is just to show kind of how painful it is to try to keep up with source code separation manually, how convenient it is to have a build system make those changes for you. Now that we've talked about the process that we go through to build our applications, to talk briefly about the tools that allow that to happen automatically. We're using Gulp for this project. Other people we know use Grunt. It's also a very popular one. Both of them are task runners that run using Node.js, and they're similar but different, and we went with Gulp because it was what we were most comfortable with. It's just something that you should decide and choose whichever one you're most comfortable with. As we built our build system in Gulp, we identified the steps that we needed to do to make our process work, and then we created Gulp tasks that would be responsible for different parts of that build process. An example of different build tasks are outlined here. One that loads the environment, one that does the configuration based on the environment, one that copies the source, one that copies the configs, and one that after everything's copied and everything's settled down, it just watches for code changes in any of those locations, and then responds to the code change as necessary if it's copying a file over to the build application, or if it's rerunning the whole environment configuration process over again. The watch tasks are what keep the build system running. Back over to you, Nick.
All right, so we're going to take a minute to dive in a little bit more on how we do the environment configuration and what it looks like. So typically when you're building an application, it has references to environment-specific items, such as endpoints are a great example. So if you're writing a widget that interacts with a geoprocessing tool that's running on a server, you're going to have the endpoint of that geoprocessing tool. And then if you've got ArcGIS Enterprise stood up in a development environment, and then a production environment, a staging environment, and it's a different instance of ArcGIS Enterprise, it's not going to be the same endpoint that you use throughout those different environments to execute that GP tool. So a typical configuration, very simplified configuration, looks like this, where you have a service and then the URL of the service that you have the exact endpoint filled in for. But like we said, that's not exactly what we need for all the different environments. So we really need 3 different environment files. We could manage 3 versions of the same environment file, but that gets a little bit tedious, especially if you're dealing with many different environment-specific variables. So the way that we do this is it builds on the Gulp task runner that we were showing earlier. But we have 3 different files, JSON files, that contain only the variable name and then the variable itself. So it'll have a variable name of like service 1, and then the service for dev, and then the service 1 in staging, and the service for staging, and same with prod. And then we'll, instead of having a config file that has the value, we'll put a variable in the config file, and that's what we end up source code controlling. And then once we run this through our build system and pick one of these 3 environments, we'll output the config file the way that we need it to be. So the way that it would have been had we written it specifically for that environment to start off with. This is a little bit misleading, this graphic, because it doesn't It doesn't pick from all three of these, it's one of these, and then it feeds into gulp, uses this templated config, and then it outputs one of these three, depending on which environment you built it for. So let's take a look at an example of this so we can kind of see how it works for real. So this is the one of the repositories I have. It's called web dev env sample with my name. So go ahead and get that, and I already cloned the repo, so let's open it up in Visual Studio Code. The first thing you're going to want to do when you get it is run an npm install on it so that you've got the node modules pulled down. So you'll see, let's close this. Here are the environment files that we're talking about: dev, JSON, production, and staging. These are just simple JSON files that have that variable and then the actual value for that variable for the different environments. So for production, I've just got prod submit job, and for staging, just staging at submit job. So the configs folder represents a configuration of a widget that we have, just called my custom widget. So this one doesn't have a whole lot, it's just got that single service in it. And then here is the @@ variable name @@ that we're going to replace. Then if we run just the standard gulp command, it will use the dev environment by default. That's just how the build system that we've got here is configured and is set up. So it'll pull the dev environment by default. But the output of everything goes to this WAB folder. So I don't have all of the Web AppBuilder stuff in here. I'm just outputting, the small amount of stuff that I've got configured. But if you look at the configs, this is the built widget JSON. So this one has the right endpoint for the dev environment that I just ran. If we kill this and we do gulp env equals production and run that, it will pick up the production environment file and rebuild this configuration with the right URL. So that's how the variable substitution works. All of the code for doing this, this is a real simple example of this, but it's in the single build.js file. So you'll see all the code here and what it's doing. But that's a way that we can rip through environment files and build configuration files for, not just Web AppBuilder. This same sort of concept can be used for anything. It's handy for Web AppBuilder because a lot of the configurations end up getting stored in the widget configs, which if you've got a large number of widgets in your application, it could be spread out through multiple files. So that's an example of kind of how we do that, simplified, extracted from the bigger build system that we showed earlier. So the next phase of the pipeline is the testing phase. I'm not going to spend too terribly much time on the testing phase because there are other examples out there and resources about unit testing strategies for Web AppBuilder. I think some of the examples that they have use something called intern. We oftentimes, at least on the projects that I've worked on, we use Mocha, and there is a gulp package for Mocha called Gulp Mocha, which will allow you to kick off your Mocha unit tests using gulp, so it can be integrated into a build system that uses gulp. I do definitely, you can skip the unit testing part, but I do encourage you to unit test applications, especially when you're writing enterprise level applications. They really allow you to test the the nitnoid fine-grained details of the code that you've written to make sure that it's working under various inputs. Unit tests allow you real fine-grained control over the parameters that you send into functions, and then you can make sure that they're returning the right things. And if you've architected your application well, then if you change how a method is implemented, but you're not really changing the output, you're just optimizing it or modifying it or refactoring it, the unit tests will apply and make sure that you didn't inadvertently break something as you were refactoring the code. So it's a real good thing to include into the build pipeline. And we've got ours set up so that if a commit is attempted to be made to the repository and it can't be, not none of the unit tests, but some of the unit tests don't pass, the commit will not be allowed to go in. So then the developer has to take a look at, either the unit tests are out of date because they changed code and they didn't change the unit test to match, or they actually inadvertently broke something when they were applying the changes that they were making. So unit testing is a really good thing to have in place for larger applications.
Another good step to do before deploying your enterprise application is to minimize your code. In our build system, we have a gulp task for exporting our application. The export task has two key parts, one for exporting a debug version and one for exporting a production version. The difference is that the debug is just a zipped up file of our web application, and the production version is a minified version of our web application. Our build system relies on the npm library Esri web build to minify and package up our web application for production deployment. And we're using our build system uses these scripting options for building our apps. So in order to run this, we just run gulp export. At this point, we get to choose our environment. We're going to choose staging. But this process takes about almost 4 minutes in this particular example. Now that the build is finished, we have a new .deploy/staging folder with 2 WAR files inside it. And one of them ends in the word debug, and that is our debug version of the application. It will be non-minified. The myapp.war file is the minified version, and if you'll notice, it's much larger than the non-minified version. The reason it's much larger is because it has a copy of the JavaScript API built into it now, so that it doesn't have to make any external server requests for that. It'll have all those files locally on the server where you deploy it.
And finally, the pipeline ends with the deployment phase. So there's, just like with everything else, there's several ways that you can accomplish this. We're actually deploying our applications in a production server to Tomcat. So the process that we use is as follows. We zip up the applications using another gulp package called gulp zip. And then Tomcat is actually expecting WAR files, which is just a zip file that's renamed a WAR. So we use our build system to change the file extension of it. And then we use another node module called node SSH, where we actually SSH into the server that we're deploying this to. And in the case of Tomcat, we're copying that WAR file to the apps Tomcat folder. And then once Tomcat recognizes that the WAR is out there, it goes ahead and unzips it and deploys it. So that's one way of doing this. Another way that you could do it would be to use Docker. If you're using Docker for any of your production stuff, that's an option. But ours, and when we have multiple web servers out there, we just SSH into the list of servers that are running the web applications. So if we've got 4 of them, there's the IP addresses of the 4 machines that we can SSH into and lay down the applications. So that ends the pipeline. So what we just showed allows us to go from a developer making a commit to a repository. Jenkins notices that commit that's been made. It checks out the code. It runs it through each phase of that pipeline, and then it ends up with the deployment phase. So in our development environment, each time a developer makes a commit to the repository, either the master branch or the develop branch, whichever is your main branch of your repository, we go ahead and automate the building of the application and the deployment of it. So, developers in that environment don't have to do anything. Same thing would happen for staging too. So you don't have to manually do anything to push out your latest web application to get QA testers involved in testing it. It's just automatically deployed. So that's typically the workflows that we use for the applications that we develop. Now we're going to talk a little bit about really kind of architectural concepts that you might want to consider when you're doing Web App Builder development. The focus typically when you're writing custom applications and just getting started with custom Web App Builder is to just write a custom widget. So the habit people fall into is that they put all of the code in the widget folder itself. I mean, you may get a little bit more advanced where you actually break that out into multiple classes that are in the widget folder, but it's still in the widget folder. If you're writing logic that is really application level logic, I don't think it belongs in the widget. So we typically pull it out. There is a libs folder that exists in Web App Builder if you look around in that folder structure. And that's a lot of where like the application level Web App Builder framework stuff goes. So you don't have to name it custom libs. You can name it like your application / libs and then put your logic in there. So the reason why you would do this, I mean, there's many. Just having application level logic separated from the user interface logic is a really good one. And then there's times where we've come across instances where we wanted to share the same UI throughout multiple widgets. So this is an example of when we've done that. There's two different widgets. We have a filter that filters by space and time and a filter that filters by attributes, but they wanted a footer on each one of those to show the current amount of data that was selected in that filter. So, if we would have written the space-time filter widget and had this code in there, it would have been, you couldn't have brought it into the attribute filter as well. Worst case, you end up duplicating the logic that puts this in there, and now your application has the same logic in both the space-time filter widget and the attribute filter widget. So you wouldn't want to do that. You would want that to be a shared component and then have that component somewhere in your file structure where both of these widgets can load that in. The same is true for application level logic in utilities. So this is shared UI. You can share business logic classes as well. So there is a drawback to doing this. If your main driver is to build a custom widget and then easily share that custom widget with other applications, this makes that more difficult. You can't just take your widget folder, package it up in a zip, and then say, here you go, here's my custom widget that's available for you to easily load into your own Web App Builder application. In order to do that, you would have to package up your widget and all the shared code that goes with it, which is doable. It just gets a little bit more involved. And we do this for a lot of our enterprise applications. We have such a thick application business logic layer that there's a lot of code that lives in there that drives the application user interface that it just, and it's not what we're trying to get at. We're not trying to share these widgets. So it's not something that we run into with what we do, but just be aware of, if you're trying to make portable widgets, this makes it more difficult. So a couple other things that we've got, really when you start looking around inside of what you get with Web App Builder, there's a lot there. Take a look around, take a look at the utilities that are in there. There's a lot of utilities and a lot of classes in there that you may want to use. When you get into doing what we're doing with this, where we're maintaining the configurations in our own source code, and we're swapping out the environment or the variables with environment variable, or the values with environment variables that we replace, and everything else that we do with this, you really start getting away from using the WYSIWYG editors in Web App Builder. So you need to understand how those configurations are built yourself, and having a good grasp of JSON, because all of those configurations are JSON, is key. So that'll help a lot. jimu.js is the core component of Web App Builder, and there's a lot of really good stuff in there. The developer docs for Web App Builder are good, but they're not as good as actually going and looking at the source code. So there's a couple utilities in there that we use. There's a CSV utils, GeoJSON converters, and this whole slew of digits for the UI components that are in Web App Builder that you can use or modify. when you get into looking at those and using those internal classes and modifying those internal classes, you got to be a little bit more careful, because if you upgrade Web App Builder versions and the Web App Builder team has modified those, they could change something that you are relying on. So you do have to be mindful when you're digging around in there. But it's a lot of really good examples of how Web App Builder itself is built. So take a look at those for sure. Thank you, everybody, for joining us. That's all we've got to share for this session. Hopefully this was helpful and gave you a little bit of insight into how we do really enterprise development with Web App Builder with large custom applications. Thank you, everybody.